All right, our first video of this unit is going to be just an introduction to radicals. So make sure you put today's date in the top corner of your notes. And then our title here is Intro to Radicals. So you've seen radicals in other classes before, and actually in this class as well. You've seen them a lot when we've dealt with square roots. So square roots are actually radicals. We just use radicals as the official name for them. So we're going to type in this little sheet here to put into your notes to help with kind of understanding what radicals are. So the first thing we're going to talk about is when you square a perfect number. So remember, when you square a perfect number, it means you multiply a number by itself. That's a perfect square. So in this example, if I have 1 squared, that just means 1 times 1. So 1 squared is just 1, because 1 times 1 is 1. You're not doing 1 times 2, you're doing 1 squared. And so remember, on your calculators, if you wanted to type this in on your calculator, the x squared button is right here. So if I wanted to do 1, I would type in 1 and then squared, and I can get my answer. So I can go through that with all of these. 2 squared is 4. 2 times 2 is 4. 3 squared is 9. 3 times 3 is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 49. 64. 81. 100. 121. 144. 169. So as I'm going through, you're just thinking what number multiplied by itself gives you these numbers. And if you don't trust me, you can type those numbers in and see what comes out. So like 14 squared should be 196. 15 squared should be 225. 16 squared is going to be 256. I believe 17 squared is 289, but let's double check on the calculator. Yep, 289. 18 squared is going to give us 324. 19 squared is 361. And then 20 squared is 400, because 20 times 20 is 400. So this shouldn't be anything new to you. You should be able to calculate perfect squares when you square an integer. And on the flip side of that, you have the undo of a square, which is the square root, and that's called simplifying a radical. So the square root of a number x is a number that multiplied by itself equals x. So when you're square rooting, you're basically just asking what number multiplied by itself gave you that number underneath the square root sign. So what number times itself gives you 1? Well, there's only one possible answer. That's 1. Square root of 1 is 1. What number times itself gives you 4? That's 2. Square root of 4 is 2. Square root of 9 then would be 3. 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. 81 is 9. And then 100 is 10. So what number multiplied by itself gave you that number? So that's all stuff you should know already about radicals. Those are the radicals you've seen. We've also seen radicals with cubes. So if you multiply a number by itself 3 times, so 2 times 2 times 2, or 3 times 3 times 3, and then a cube root. So some examples of cube roots, and we won't go through as many as we did with the square roots. So some cube roots we have. So cubes of integers are perfect cubes. Some examples we would have would be 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, because that means 3 times 3 times 3. 4 cubed would be 64, because it's 4 times 4 times 4. And then 5 cubed would be 125. To simplify, a cube root, you ask yourself what number multiplied by itself 3 times gives you that answer. So here, the cube root of 1 is 1. The cube root of 8 is 2. The cube root of 27 is 3. The cube root of 64 is 4. And the cube root of 125 is 5. All right, so we have the cube root of 125 is 5. So on your calculators, if you want to do cube roots and cubes, you got to use different buttons. So if I wanted to raise something to the third power, I would type in my numbers. Let's say I want to do 2 to the third power. I would do 2, and then you hit this caret button for a different exponent. So 2 to the third, you have to shift out of there, is 8. If I'm looking at doing the cube root, you have to hit the button Math. And you could use number 4 for cube roots. Number 5 I like showing because for number 5, when you type in your cube root there, you just got to delete that little part there and type in a 3 for the cube root. And you could do any number then, so you can do other roots besides cube roots. You could do 4th roots, 5th roots, 6th roots, just by deleting that number there and changing it to whatever you need it to be. So for our question, I said the cube root of 8 would give you 2. For cube roots, there's also another button that just directly gives you cube root, which is that one when you hit Math. So you go to Math, number 4. So that's cubes and cube roots. So these are the radicals you've probably seen in some class before. What we're going to start looking at is defining some more parts of radicals and then using them in other problems and simplifying. All right, so some parts of radicals that you're going to have to get comfortable seeing. All right, so the parts of the radical that you would see, let's say I gave you this number, the cube root of 20. It's not really a nice number to cube root, but we can kind of break down some pieces of this symbol. So the first thing is a little number here in the corner is called your index. And that just tells you what the root is of the radical. So in this problem, the index is 3, which means it's a cube root. So I'm looking for the number that multiplied by itself gives you 20. The check mark looking box thing is called the radical symbol. So when I say radical, that's the symbol I draw. And then the number underneath the radical is called the radicand. And that's the number that you're looking for, that you're looking for the number that multiplied by itself 3 times gives you this number. So those are the parts of a radical, those are the new things. And we're going to be dealing a lot with this number here as we look at our problems coming up in the future. One thing to note, if an index is not listed, the index is 2. So as an example, if you had a problem like the square root of 50, just like that, there is no index listed right there, so we know it's a 2. That's the only number that is not going to be written, would be the 2. Otherwise, you'll always see a number written there telling you what root that you're taking for a radical. And that's really it for radicals. That's the intro to them. We're going to start looking at how to simplify them and work with them in our problems coming up for the rest of the week. All right, so that concludes the intro to radicals. You can start with the very easy practice problems tonight, just finding square roots and cube roots.